May 2024, across the vast agricultural heartland of the American Midwest, something invisible began to break the world. Thousands of high-tech tractors, guided by GPS systems accurate to within a single inch, suddenly veered off course or stopped dead in their tracks. Farmers watched their monitors glitch and fail as the primary coordination for modern food production simply vanished from the sky. This wasn't a cyber attack. It wasn't a software bug. It was a warning shot from a star 93 million miles away. At the same time, orbiting high above the atmosphere, 40 SpaceX Starlink satellites were being cooked alive, their electronics overwhelmed as the very air around them thickened, dragging them out of the sky to burn up in a multi-million-dollar pyre of silicon and metal. We call this space weather. But that term is a polite euphemism for a celestial violence we are fundamentally unprepared to survive. Most people believe the greatest threat to our civilization is a pandemic, a nuclear exchange, or a slow-motion climate collapse. They are wrong. Our greatest vulnerability is the invisible umbilical cord connecting our digital existence to the volatile whims of the sun. We have built a glass civilization on a foundation of electricity, and we have done so during a period of solar silence that is historically freakish. We are living through a statistical anomaly of calm, and the data suggests that the storm is not just coming, it is already overdue. If you think a Carrington-level event is our worst-case scenario, you have been lied to. The truth buried in the rings of ancient trees and the ice of the poles tells a much darker story. To understand the scale of the threat, we have to look at the 1859 Carrington Event. This is the gold standard for solar disaster in the public consciousness. In September of that year, British astronomer Richard Carrington witnessed a blinding white light flare on the sun's surface. Hours later, the Earth's magnetic field was slammed by a coronal mass ejection so powerful that telegraph lines sparked spontaneously, setting offices on fire and shocking operators. The northern lights were so bright in the Caribbean that birds began to chirp, thinking it was dawn. In 1859, the only thing we had to lose was the telegraph. Today, we have everything to lose. But here is the problem. The Carrington event was not the big one. It was a minor spark. In 2012, a researcher named Fusa Miyake was examining the growth rings of a 1,900-year-old Japanese cedar tree. She wasn't looking for space weather. She was looking for history. What she found was a spike in carbon-14 so massive it defied every known model of solar physics. Carbon-14 is a radioactive isotope created when cosmic radiation hits our atmosphere. It's a chemical timestamp. Miyake discovered that in the year 774 AD, the Earth was hit by a solar storm 20 times more powerful than the Carrington event. Since then, we have found evidence of these Miyake events scattered throughout history: 7,176 BC, 5,259 BC, 993 AD. These are not once-in-a-million-year anomalies. They are a recurring feature of our solar system. If a Miyake event hit us tomorrow, we wouldn't just be looking at a few sparks in a telegraph office. We would be looking at the permanent erasure of the global electrical and digital record. The danger is not just that the lights go out. It's that the very logic of our machines begins to lie to us. We saw a terrifying preview of this in 1972, during the height of the Vietnam War. Off the coast of Hon La, thousands of U.S. Navy sea mines, designed to detonate only when they detected the magnetic signature of a passing ship, suddenly exploded all at once. There were no ships. There was no enemy. There was only a massive solar flare that had tricked the mines into thinking they were under attack. This is the logic collapse. It's what happens when the physics of the universe overrides the programming of our technology. Consider our railway infrastructure. We trust signals to keep trains from colliding. These signals operate on low-voltage electrical circuits. Research now shows that a severe geomagnetic storm can induce currents in the tracks themselves, flipping a red stop signal to a green go signal. It's called a wrong side failure. It is the most catastrophic type of failure possible because the system doesn't just stop. It tells you that everything is safe when a high-speed collision is imminent. This is the insidious nature of space weather. It doesn't just break things, it makes them untrustworthy. But perhaps the most fragile link in our global chain is the one we never see: the bottom of the ocean. We think of the internet as a cloud, but it is actually a series of physical tubes, fiber optic cables, stretching across the seabed. While the glass fibers themselves are immune to magnetic interference, the cables require electrical repeaters every 50 to 100 kilometers to boost the signal. These repeaters are powered by a long copper wire that runs the length of the cable. During a solar storm, the Earth's magnetic field fluctuates, inducing massive currents in these long-haul lines. A Carrington-level event could fry the repeaters across the Atlantic and Pacific simultaneously. This is what scientists call the Internet apocalypse. If the undersea repeaters fail, the Internet doesn't just get slow. It ceases to exist between continents. And unlike a power transformer on land, you cannot simply drive a truck to the ocean floor to fix it. We only have a handful of specialized cable-laying ships in the entire world. It would take months, perhaps years, to restore intercontinental communication. In that time, the global economy would vanish. Supply chains would evaporate. The just-in-time delivery systems that put food on your grocery store shelves would collapse because the data required to coordinate them no longer exists. While we worry about the cables and the grids, we are ignoring the fact that our planetary armor is failing. The Earth is protected by a magnetic shield called the Magnetosphere. But this shield is not a solid wall. It is a shifting, organic thing, and it is currently weakening. Scientists have identified a massive leak known as the South Atlantic anomaly. In this region, the magnetic field is so weak that satellites passing through it often experience single-event upsets. Their computers reboot, their sensors go blind, and their hardware degrades. This anomaly is growing and moving. As our magnetic shield thins, even moderate solar storms, the kind we used to shrug off, become existential threats. This brings us to the great grid debate. On one side, you have the utility companies and organizations like the Electric Power Research Institute. They argue that our power grids are resilient, that we can simply unplug the system or use protective relays to prevent a total meltdown. On the other side, you have national security experts and solar physicists who warn that this is a dangerous fantasy. They point out that the high-voltage transformers that form the backbone of the grid are custom-built, weigh hundreds of tons, and take over a year to manufacture. We don't keep spares in a warehouse. If a solar storm melts the internal windings of just a few hundred of these transformers, the lights don't just go out for a few days, they stay out for a decade. Imagine a world without electricity for a year. No refrigeration, no water pumps, no fuel lines, no banking, no communication. This isn't a post-apocalyptic movie. It is a scientifically plausible outcome of a Miyake event. In 1967, we almost learned this lesson the hard way. During the height of the Cold War, the U.S. Air Force prepared for a nuclear strike after its polar surveillance radars were suddenly jammed. The military assumed the Soviet Union was initiating a first strike. It was only at the very last second, thanks to the intervention of the newly formed Solar Forecasting Unit, that the Pentagon realized the jamming was actually a massive solar flare. We were minutes away from accidental global thermonuclear war because we didn't understand what the sun was doing. The sun is currently entering solar maximum, the peak of its 11-year cycle of activity. This cycle, known as Solar Cycle 25, is already proving to be much more intense than initial forecasts predicted. We are seeing more sunspots, more flares, and more coronal mass ejections than we have in decades. And yet, our society is more dependent on microchips and precision timing than at any point in human history. Every time you tap your phone to pay for coffee, you are relying on a timestamp from a GPS satellite. Every time a plane lands in the fog, it is relying on a signal that must pass through an ionosphere that can be turned into a chaotic soup of radiation in a matter of seconds. We are also populating low Earth orbit at an unprecedented rate. Thousands of satellites are being launched every year, creating a shell of technology around the planet. But these satellites are vulnerable to atmospheric drag. When a solar storm hits, the upper atmosphere heats up and expands. Satellites that were once orbiting in a vacuum suddenly find themselves flying through a thin fog. This slows them down, causing their orbits to decay. In a massive storm, we could see a Kessler syndrome event triggered not by a collision, but by the sun, as hundreds of satellites lose altitude and crash into each other, creating a cloud of debris that traps us on Earth for generations. So, why aren't we doing more? The answer is a mix of psychological denial and economic inertia. Hardening the power grid would cost billions. Building a backup internet would cost trillions. It is easier to hope that the Miyake events of the past were black swan events that won't happen in our lifetime. But hope is not a strategy. The sun doesn't care about our quarterly earnings or our political cycles. It is a nuclear furnace that operates on a timeline of billions of years, and it is currently staring us down. The May 2024 storm was a G4 class event. It was beautiful. It produced auroras that were seen as far south as Florida and Italy. People took photos and marveled at the wonder of nature. But for those who know where to look, it was a terrifying display of vulnerability. The failure of the John Deere RTK GPS systems wasn't just a glitch. It was a demonstration that our most advanced automation is built on a house of cards. The RTK system relies on ground-based base stations to correct satellite data to centimeter-level accuracy. The solar storm distorted the ionosphere so badly that the corrections became errors. The machines were lied to by the atmosphere itself. We are entering a new era of solar awareness, but the gap between our knowledge and our preparation is widening. We know about the carbon-14 spikes in the trees. We know about the sea mines in Vietnam. We know about the 1989 Quebec blackout that plunged millions into darkness in seconds. We know that the Carrington Event was a warning, not a limit. And yet, we continue to tether our lives more tightly to the very systems most likely to fail. The next great storm will not give us years of warning. We will have about 15 to 30 minutes from the moment the satellites at the L1 Lagrange point detect the impact to the moment the grid begins to groan. In those 30 minutes, every major utility provider on Earth will have to make a choice. Do they stay online and risk total hardware destruction? Or do they preemptively shut down the world, plunging billions into darkness to save the machines? It is a choice between a temporary dark age and a permanent one. The narrative of human progress is often told as a story of our mastery over nature. We have split the atom, mapped the genome, and built a global brain made of silicon and light. But all of that mastery is contingent on the silence of our star. We are like residents of a beautiful village built on the slopes of a volcano that hasn't erupted in living memory. We have mistaken the volcano's silence for its death, but the trees remember, the ice remembers. The carbon-14 is there, etched into the wood of the ancient cedars, telling us that the fire will return. When it does, the first sign won't be a bang. It will be a silence. Your phone will lose its signal. The GPS in your car will show you driving through the ocean. The lights will flicker once, twice, and then go dark. And in that darkness, for the first time in a century, the entire human race will look up and see the northern lights dancing over cities that no longer have the power to drown them out. It will be the most beautiful thing we have ever seen, and it will be the signal that the world we knew is over. We are currently in a race against the solar clock. We are developing new ways to shield our satellites and more resilient ways to build our transformers. We are launching new missions like the Parker Solar Probe to touch the sun's corona and understand its secrets. But the scale of the challenge is immense. To truly protect ourselves, we would need to rethink our entire relationship with technology. We would need to build systems that are locally autonomous, grids that don't rely on long-distance transmission, and communication networks that don't depend on a single copper wire at the bottom of the sea. But until then, we are at the mercy of the space weather. We are living in the long calm, a period of solar tranquility that has allowed us to build a digital empire. But the sun is waking up. The sunspots are growing. The magnetic fields are twisting and snapping. And somewhere, deep in the heart of our star, a CME is forming that will eventually find its way to Earth. It won't be a matter of if, but when. And when that day comes, we will find out if our glass civilization can withstand the heat of a star that is finally done being silent. The evidence is clear. The Carrington Event was a drizzle. The Miyake events are the flood. We have been warned by the trees, by the ice, and by the very machines that have already begun to fail. The storm is not just a possibility, it is a mathematical certainty. We are a high-tech species living on a low-tech planet, protected by a thinning shield, orbiting a volatile star. The only question that remains is whether we will use this window of calm to prepare, or if we will remain distracted by the glow of our screens until the sun itself turns them off. The story of space weather is the story of our own fragility. It is a reminder that for all our brilliance, we are still small, and the universe is still very, very large. We are the architects of a world that can be unmade in an afternoon by a single burst of solar wind. As we move deeper into the 21st century, our survival may depend not on our ability to innovate, but on our ability to remember the lessons of the past, the lessons written in the rings of the trees and the silence of the sea mines. The sun is giving us a warning. It is time we started listening.